Hello students, welcome everyone. So this is a video I'm making regarding the problems related to free convection. So we have seen enough of theory in the last class regarding free convection, that is the mechanism of free convection, what are the different non-dimensionless numbers that are available in the free convection. So all those the basic things we have seen. So now I think you are in a position to understand the problems related to free convection. So as I have already shared the no tutorial problems with you, here in this video I am going to share the steps involved in solving a problem. So I am taking the tutorial sheet number 9, as you can see here. So I have taken the tutorial sheet number 9, and this first problem is related to free convection from plates. So this first problem is related to the free convection from the plates. So usually you can get a problem related to free convection with respect to the flat plates and cylinders based on its positions. That is, for example, a flat plate which has been placed vertically and flat plate which has been placed horizontally. Similarly, in horizontal flat plate, you can get two cases where the hot plate facing upwards and hot plate facing downwards. And similarly, in cylinders, cylinder placing vertically and horizontally. So these are the type of problems. These are the type of orientations of flat plate and cylinder that you can get. So problems related to these kind of configurations you can expect in the exams. So in this video, let us now see how to solve a problem related to free convection. So here I have noted down the problem that is in tutorial sheet number 9. So you can read here, a vertical flat plate 300 mm high and 1 meter wide, maintained at a uniform temperature of 120 degrees centigrade, is exposed to quiescent air. Quiescent means still air. This is nothing but still air, means there is no movement. Quiescent air which is at 30 degrees centigrade. Calculate the average heat transfer coefficient and the total heat transfer rate from the plate to the air. So this is the question which is there in the tutorial sheet number 9. Now let us now try to solve this problem. So you please keep this problem along with you. You write it or you copy it, or you have a printout, you can take it and keep it. Now what is the first step of this problem? So as we were doing in the forced convection, similarly, so write down. So I'm going to start here. So this is the solution here. Now please try to write down a small sketch, as I'll be doing in the class, every class, that you are supposed to write a small sketch for the given problem. So it is a vertical plate. So plate is made to plate has been placed in a vertical manner. So write a small sketch here. So this is the vertical plate you are having. So this is a vertical plate which is placed in the atmosphere. So having a length, so this is the L, and so it is 1 meter wide they have given. So you can consider this is the 1 meter high, 1 meter wide, and so this is the height. You can consider this is the length or the height, whatever it is. So this is the length, and wide is this much. So this is, you can, if you want to write it, you can write this particular structure something like this. So this is the width. So you can see the length or height is equal to 300 mm. So this is equal to 300 mm, and this width which is equal to 1 meter. I hope you can see it here. Now, so this is the problem given. So this is maintained at T surface, which is maintained at how much? You can see here 120 degrees centigrade. So the atmosphere which is surrounding this, or the air which is surrounding this flat plate, so that is T infinity, which is maintained at 30 degree centigrade. So now what is the solution? So let us try to write given here. So whatever that we have written here, let us try to write it here. So given Ts equal to 120 degree centigrade and comma T infinity equal to how much? 30 degree centigrade, that is the atmospheric air temperature. Then you can write it out. The length is equal to 300 mm, which is equal to 0.3 meter, and width is equal to 1 meter. So only this is the information that we are having. So what are the things that we need to find out? You can read the question here. So first is average heat transfer coefficient. So please be careful about this word. This is average heat transfer coefficient and total heat transfer rate. So these are the things that we are supposed to find out. So average heat transfer coefficient is question mark, and total heat transfer rate, so Q is equal to question mark. Now let us now try to see how to solve this problem. So you know already, like you have solved in forced convection problem. So the first thing is what we have to find out the properties. So like you have done, find out how do we find out the properties in forced convection. Like first we need to find out the mean temperature or film temperature. So even in forced free convection also, first we are supposed to find out mean temperature. So your T mean equal to what? Ts plus T infinity divided by 2. So which is equal to how much? Which is 120 plus 30 divided by 2. So Tm is equal to how much? 120 plus 30 is 150. 150 divided by 2, which is 75 degree centigrade. Now from heat transfer data handbook, from heat transfer data handbook, you know already this short form, heat transfer data handbook, at 75 degree centigrade for air, find out the properties for air. So we have to find out the properties. I have already the properties with me. You have to find out in the exam. You are supposed to find out the properties for the air. So they have given it as the air. So for the air, from the data handbook, find out the properties. So I have the properties here. I am going to give it to you. So Prandtl number comes out to be around 0.693, so which is a non-dimensionless number, and kinematic viscosity is 20.555 into 10 to the power of minus 6 meter square per second. And then your K, that is thermal conductivity. So thermal conductivity is around 0.03 into 10 to the power of minus 3 watt per meter Kelvin. Then your beta, okay, we have to find out the beta here. So you know, I already have told you beta is a very important parameter that we need to find out when it comes to free convection. It is volume expansion coefficient. So beta is equal to what? It is 1 by Tm. So be very careful, and already I have told you beta should be in terms of Kelvin. It is per Kelvin. So what is that we need to do? 1 divided by, so our Tm is found out to be 75. So 75 plus 273. So when you calculate this, I have calculated it. So it is coming out to be around how much? So it is coming out to be around 2.873 into 10 to the power of minus 3 per Kelvin, or Kelvin to the power of minus 1. So please note this. So it is coming out to be around 2.873 into 10 to the power of minus 3. Now, so we have found out the beta. So these properties are enough for finding out the other parameters. Now the next, so in force convection, what is the next step after finding out the properties? We have to find out whether the flow is laminar or turbulent. So similarly here, there in force convection we used to find out the Reynolds number, but in free convection we are supposed to find out the product of Greshoff's number and Prandtl number, which is called as Rayleigh's number. So we have to find out the product of Greshoff's number and Prandtl number. So in order to find out that, let us try to find out the Greshoff's number first. Okay, so let us try to find out the Greshoff's number. So Greshoff's number, I am not finding out the local Greshoff's number. So we are finding out the Greshoff's number at the end, that means at L. So Greshoff's number GRL is equal to what? You know already, G beta delta T into L cube divided by nu square. So which is equal to how much? So try to substitute 9.81 into 2.873 into 10 to the power of minus 3 into, so delta T is how much? So you can see delta T is here 120 minus 30. So I'm directly writing it. It is coming out to be 90. Delta T is that. Then into L cube. So L cube is how much? L we found out here, it is 300. So which is 0.3. So be careful, everything should be in terms of meters. 0.3 cube divided by nu square. Nu is how much? So 20.55 into 10 to the power of minus 6 square. So what is the value of GRL? So when you try to calculate these things, you are going to get the Greshoff's number as 162.1 into 10 to the power of 6. So similarly here also you can find out the Greshoff's number at any point. Okay, you have X also. So in the place of L here, in the place of L, you have to put it as X in any problem. Other than this, in any other problem, if they ask you to calculate the local Greshoff's number, you have to just replace the L with the X at any point in the flat plate. Okay, so please make a note of it. So our Greshoff's number at L is coming out to be around 162.1 into 10 to the power of 6. So you have to confirm this by calculating by yourself. Okay, now next, what is the next step? So next step is to find out the product of Greshoff's number and Prandtl number. Okay, let me do it here itself. So if you try to find out the next step, what is called as Rayleigh's number, finding out Rayleigh's number, that is RAL, which is nothing but equal to product of GRL into Prandtl number, which is nothing but equal to 162.1 into 10 to the power of 6 into what is Prandtl number? Prandtl number is 0.693. So how much is that? Rayleigh's number is coming out to be around, so 112.33 into 10 to the power of 6. So the product of Greshoff's number and Prandtl number, which is called as Rayleigh's number, is coming out to be around 112.33 into 10 to the power of 6. So why we found out this? As I already told you, we need to find out whether the flow is laminar or turbulent. Please make a note of it. So how do we find out whether the flow is laminar or turbulent? by finding out the product of Grashoff's number and Prandtl number. So now we have to decide whether the flow is laminar or turbulent. Now how do we do it? So since I'm writing it here, since Rayleigh number is less than 10 to the power of 9, the flow is considered to be laminar. So I've told you in my introductory class, if the product exceeds 10 to the power of 9, so let me write it here. So just for your case, your RAL is nothing but what? GR number into PR number. So if GR into PR exceeds 10 to the power of 9, it is turbulent. If it lies within 10 to the power of 9, it is considered as laminar. So if it is 10 to the power of 9, the flow is laminar over the entire length of the plate. Okay. Now here is what you need to be aware of. Now if you see the data handbook, there are like more relations available for calculating the average heat transfer coefficient. Okay, I'll just give few correlations which are there. If you open any textbook or if you open any data handbook, you can get lot of correlations regarding calculation. So here what is that we are supposed to find out? We are supposed to find out H average. In order to find out H average, we have to find out, first procedure is to find out the local heat transfer coefficient or local Nusselt number and then find out the average. But if you open data handbook, there are a lot of other correlations also. You can use one correlation, that is the general correlation available, that is for laminar flow. For vertical plate, we have Nu average L is equal to 0.59 into Grashoff's number, product of Grashoff's number, Prandtl number to the power of 1 by 4. So you can directly use this, since it is a very generalized correlation, and the condition to use this is the product Grashoff's number and Prandtl number should vary between 10 to the power of 4 and 10 to the power of 9. So I'm writing it in the bracket here. So definitely our Grashoff's number is coming out to be how much? Our product of Grashoff's number and Prandtl number, it is coming out to be around 112.33 into 10 to the power of 6. So very confidently we can use this. Now if you open any other textbook or something, they also give one more correlation, that is Churchill and Chu correlation, which I can discuss in the next video. So if you try to adopt this formula, you can get what is called as, you can get the result. So it is coming out to be around is equal to, so it is coming out to be around 60.740. So the Nusselt number, average Nusselt number. So how do we calculate the average heat transfer coefficient? So you know already, this is equal to what? H average into L divided by K. So therefore H average is equal to what? 60.740 into K divided by L. So which is equal to 60.740 into, so what is the value of thermal conductivity? It is coming out to be around 0.03 into 10 to the power of minus 3. Okay, so yeah, I think please make a correction here. The thermal conductivity value, it is just 0.03 into 10 to the power of minus 3 is not there. Please cancel that. The thermal conductivity value is K is equal to 0.03 watt per meter Kelvin. So if you substitute it here, so 60.740, so H average equal to 60.740 into K divided by L. So 60.740 into 0.03 divided by our length is equal to how much? 0.3. So our H average comes out to be around, so if you try to calculate it here, 60.740 into 0.03 divided by 0.3, it is coming out to be around 6.07374 watt per meter square Kelvin. So please note that the value of H in terms of free convection is a very small value. It should vary between like 5 to 20, not more than that. In a very efficient case, it is coming out to be around 20, not like hundreds or thousands. It will be very small value. Please note this. Okay, now there again, what is it we are supposed to do? We have to calculate the Q. So this thing is over. Next thing is we have to calculate the Q. So Q is equal to what is that? HA delta T. So H average into area, so it is a surface area, into T surface minus T infinity. So Q turns out to be how much? 6.074 into surface area is how much? 0.3 into 1, so it is 1 meter, into 120 minus 30. So Q will be equal to, so it is turning out to be around 163. So for 163.998 watts. So this is for one side. This is for one side. So I'll just try to. So it is turning out to be for one side. As you can see here, the flat plate on one side we have considered. So heat transfer also will be happening on the other side. So this is for one side. So therefore Q total equal to, so they have asked us to calculate Q total. So you have to multiply this by 2. So it is 2 times 163.998. So Q total turns out to be around, if you try to calculate into 2, so it is coming out to be around 327.996 watts. Okay, so please make a note of it. So like this you're supposed to find it out. So there is a procedure that we have to follow. So the first step is calculating the mean film temperature, 75 degrees centigrade. Go to the data handbook and calculate all the properties. So please make a correction. K is 0.03 watt per meter Kelvin. Calculate beta, which is a very important step. Calculate Greshoff's number, so which is turning out to be 162.1 into 10 to the power of 6, and Rayleigh number, which is product of Greshoff's number and Prandtl number. So you have to conclude that whether the flow is laminar or turbulent. So you can see here, since RA is less than 10 power 9, the flow is laminar. This is a very important judgment that any student has to make. Next, go to, so in the next video I'm going to discuss on, there are number of correlations available. Please make a note of it. You have Churchill and Jew, and also there is one more procedure, like you can calculate the H local Nusselt number and then go to average Nusselt number. So this term little bit is going to vary, but you need not have to worry. You can use whatever formula that is available in the data handbook. 2 or 3 correlations available. So according to the product whatever that is available, you can use it. Okay, so we got this, we found out H average from Nusselt number. Then you have to find out Q. So you know already Q is equal to HA delta T. For one side it is turning out to be 163.998. For two sides it is turning out to be 327 watts. I hope you have understood this problem. So please you personally go and try to calculate everything and check the answers. Okay, thank you.